Welcome students. Today we're discussing the new operator and anonymous objects. So getting started. Consider an expression such as the following using the toy class. Toy class. Wow, that's a lot. Toy class variable 1 is equal to new toy class Joe 42. The portion new toy class Joe 42 is an invocation of a constructor. And we've talked about constructors multiple times in the past. So if we look at this, we have, you can think of this as the constructor is returning a reference really to the location in memory of an object created by the constructor. Now if you take this view, the equal sign in this line of code is pretty much at this point then just an ordinary assignment operator. So let's talk about that new operator. Now there are times when you create an object using new and use the object as an argument to a method, but then never again use the object. In such cases, you do not need to give the object a variable name. You can instead use the expression with the new operator and the constructor directly as the argument. For example, suppose you want to test to see whether the object in variable 1 is equal to an object with the same number and with the same name spelled in all uppercase. You can do as follows. If variable 1 equals new toy class Joe 42, this is another print line equal, else this is another print line not equal. So here's an equivalent code to that quick example we just saw. Toy class temp equals new toy class Joe 42. If variable 1 equals temp, system on the print line equal, else system on the print line not equal. You know, it's the exact same thing, except now we created that object. So in that second version, like I mentioned, we created the object, and then that reference is placed into the variable temp. Then temp is plugged in for the parameters of the equals method. But all the parameter passing mechanism really does is take the reference stored in temp and then just plug it into the parameters for equals. The first version simplifies this process immensely. You notice it was less lines of code, for example. It creates a reference to the object and plugs it directly into the parameter in equals. It bypasses the variable temp, but ends up plugging in the same reference as the argument equals. So let me just flip back real quick here. And if we look at that, that was this line right here. If you notice, we had variable. We just, rather than going ahead and creating a variable named temp, we just plugged that second half of that constructor in there, the new toy class piece in there, and just tested that little snippet right there. So kind of a nice little shortcut. Now if you wanted to use temp for something, you would still have to go and create temp. But in terms of just testing for equivalency, this is the way to do it. Now let's talk about an anonymous object. When not assigned to a variable, the expression such as new toy class Joe 42 is known as an anonymous object. It evaluates a reference to an object of the class. It is called anonymous because the object is not assigned a variable to serve as its name. We will eventually encounter situations where the use of such anonymous objects is common. Now, we're going to segue here a little bit, and we're going to really quickly discuss another approach to keyboard input, apart from what we've been doing with using the scanner class. Now, I'm not saying that you have to stop using the scanner class. At this point, though, we have enough knowledge that we can actually discuss a second way that you can get input. So the input class in the course materials uses the string tokenizer class, which was covered in a previous chapter. So let me just flip over to Eclipse here. And this right here is my input example. Let me just close the other classes so they're not in the way here. There we go. And you can see here, yes, we're still using the scanner class, but we're also using the string tokenizer. Right? And the input example program is an example of use of both the string tokenizer class and the method double parse double to read multiple values, type doubled, entered into a single line, and separate with something other than just a white space. So it could be a dash, it could be whatever you set up as your tokenizer. So then the entire line is read as a single long string using the method next line in the scanner class. Long string is then decomposed into tokens using string tokenizer. The tokens are the numbers that were input, but they are of the form string values, not of the values type double. Finally, the tokens then are converted into values of type double using the method double.parseDouble. Now, you'll notice that the string variables are initialized to null. So if I look back in here, you can see right here I have string 1, string 2, and they both start off null right off the get-go. If you omit the nulls, the compiler will complain that the variable string 1 and string 2 might have been initialized before their use. Now, technically, at this point, the compiler is incorrect, but it really doesn't do us any good to try and argue with it, because you're not going to win against the compiler. It's just not going to happen. Therefore, by including null as an initial values for the variable string 1 and string 2, it keeps the compiler happy and allows us to actually run the program. So if I just do that real quick here, if I come over here and I take null off, notice it doesn't throw an error right away. However, down here, when I try to parse that string, it says right here that it may not have been initialized. And if I click a quick fix, it adds null back into there. All right. And so, like I said, even though null is just a reference pointer, just adding that null in there makes the compiler happy. All right, a quick tip using static imports. We've already seen import statements such as import java.util.scanner. There's another form of import statement which, while not really essential, can be kind of a convenience. These are what known as static import methods and are best explained with an example. All right, so it'd be convenient to write static method invocations in the following form. For example, to uppercase first character instead of having to write out the longer version, character dot to uppercase first character. If you add the following static import statement to the start of your program, you can then write the invocation of to uppercase in a desired shorter way. So import static java.lang character.to uppercase. If you add the following static import to the start of your program, you can then write the invocation of to uppercase in the desired short way. Import static java.lang character.to uppercase. The character class is in the Java package java.lang, which we haven't really discussed much yet at this point, but it's another package that you can import besides java.util. Note that you will need to get the package name as well as the class name, just as you did with ordinary input statements, such as the above import statement for the class scanner in the java.util package. Now, the package java.lang is imported automatically. It's actually already in there. You don't have to necessarily go and do a whole bunch of them. If you want some subclasses, you can do that. Now, you can use the method character.to uppercase without any import statement of any kind. But note that there's nothing special about the package java.lang when it comes to static import statements. So if you want the static side of it, you'll need that. So if you want to use the abbreviated form .to uppercase, you must give a static import statement. So even though java.lang is part of the Java libraries, you don't have to import it. If you want a static method out of there, you will need to import it. All right. So if you use the following form of static import statement, then your code can use the name of any static method in the class character without the prefix character and a dot. So import static java.lang character star. For example, consider the following. If you replace java.util.scanner with either java.util scanner or import static java.lang.character.to uppercase, with import java.util scanner, import static java.lang.character star, then you can change the statement character.to uppercase first character plus sentence dot string 1 into sentence equals to uppercase parentheses first character plus sentence dot substring. So you notice it kind of cleans it up just a little bit. All right, there's this one quick word of warning in regards to these statics. This only works with the static methods. If you try to use this with a non-static method, there's not really a way to do it. Right? You can only really kind of do this with those static methods that we discussed. Now, you can use static import statements for things such as constants as well as methods. And that's going to conclude our notes for today, folks. So, until next time.